Okay, this is the flip video for section 2.3. We're going to continue our discussion with calculating limits, and today we're going to look at using the limit laws to calculate those limits. So make sure you have your handout in front of you. You're going to fill in the right side of each of the laws. The left side's already completed, and the numbers correspond to what you'll see on the smartboard. So you can find the correct law to write in. First of all, we're going to talk about some of the values that are used on the handout. So C is a constant. Anywhere you see C appear in any of the limit laws representing a number. The limits that we're going to use are as x approaches a of f of x, and the limit as x approaches a of g of x. And it's important to note that both of these limits do exist anytime they appear in one of your limit laws. The first limit law is the limit of a sum is the sum of the limits. So the way that we're going to write this is initially we see a limit as x approaches a of the sum of two functions. And we're going to use f of x and g of x. What this law says is that we can rewrite these as the sum of two separate limits. The limit as x approaches a of f of x, which we already talked about is a limit that exists, plus the limit as x approaches a of g of x. So to give a quick example of this, I'm going to choose two functions and just show you what this might look like. So if we have f of x equals the function the square root of x, and g of x equals the function e to the x. Initially, what the problem may appear as is the limit as x approaches a of the square root of x plus e to the x. So just to go back and highlight this, what we're seeing here is what we saw here on the left side of the law. Okay, so what we know now from the limit law, it says that this is going to equal the limit as x approaches a of the square root of x plus the limit as x approaches a of e to the x. Again, focusing on our limit laws. So if we look at this part here, our limit as x approaches a of f of x, now we're looking specifically at the square root of x, and g of x is our limit as x approaches a of e to the x. So this is one way you might see the first law applied in a section. Just to emphasize this a little more, the limit of the sum, make sure that you see the parentheses that end up around the two functions. Otherwise, you're not calculating the limit of a sum anymore. Those parentheses are going to be important in some of our other limit laws, so make sure that those are present. Okay, let's go on to the second limit law. This is the limit of a difference is the difference of the limits. So it's very similar to the first law, only now we're talking about subtraction. So we have the limit as x approaches a, and again I'm putting the brackets, f of x minus g of x. So the difference between two functions, we can rewrite this as the limit as x approaches a of f of x minus the limit as x approaches a of g of x. Okay, so again, very similar to our last limit law, except now that we're focused on subtraction, we would have to pay attention to the sign. I'm not going to do an example for this law because it's very similar to the first law. So we're going to go on to the third limit law. The limit of a constant times a function is the constant times the limit of the function. So in this one, we have c appearing. C times the function f of x. And the law says that we can take the c and multiply it to the limit as x approaches a of the function. Okay, I'm just going to do a really quick example of this one. So I'm going to continue using square root of x like I did in the last example for f of x. And let's just say c is 2. So what you would see is the limit as x approaches a of 2 times the square root of x. equals 2 times the limit as x approaches a of the square root of x. So that 2 gets to move out front, and then you can evaluate the limit without it anymore, just the limit as x approaches a of the square root of x. Okay. Fourth limit law is the limit of a product is the product of a limit. So we're going through all of our math operations. So this one is multiplication. So we have the limit as x approaches a of f of x times g of x. Hopefully this will appear. Oh, different color. Okay, we're going to keep going. Equals the limit as x approaches a of f of x multiplied by the limit as x approaches a of g of x. All right, for this one, oh, I forgot my brackets. Got to make sure I have those in there so that I know I'm working with the limit of a product. And again, I have both those limits that exist, so I can separate them to their individual limits. I'm not going to do an example of this one yet either. I'm just going to keep going. We'll make sure to practice these examples in class next time. So I'm up to the fifth limit law. This one is dealing with division. The limit of a quotient is the quotient of the limits. And we do have to make sure that our limit in the denominator does not equal 0 so that we don't end up with a 0 in our denominator. So the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f of x, all of that divided by the limit as x approaches a of g of x. Keep in mind this is provided that this is if the limit as x approaches a of g of x does not equal 0, since that is the function we're looking at in our denominator. Okay, let's keep going. We're on to, oh, sorry, this is an example that we're going to see in class. I'm not going to do this for you now. So we'll start with that, these examples, next time. But we're going to move on. So talking about the product law, if we use the product law repeatedly with f of x equal to g of x, we're going to end up, sorry about that. Okay, so in our sixth limit law, what we have is the limit as x approaches a of f of x raised to a power. In this case, we're going to use n to represent the power, the exponents. So the law says that we can actually find the limits as x approaches a of the function f of x, and then that gets raised to the same exponents. So n is going to be a positive integer here, and I'm going to show you a quick example. Let's say that f of x equals x cubed. So we would be taking the limit as x approaches a of x cubed, but we can rewrite this as the limit as x approaches a of x, and then take that limit and raise that to the third power. All right. Next law. So once we apply these 6 limit laws, we need to use 2 special limits. So the first one that we have says the limit as x approaches a of c equals c. So the limit of a constant always equals that constant. We're not dealing with the variable here, so we get the exact same value. Also, the limit as x approaches a of x equals a. So in this case, when you have the limit of a function and you're taking that function and approaching some value such as a, it's going to equal the same value a. Confused now? All right, we're up to law number 9. So if we put f of x equals x into the power law and we use law 8, the one we just looked at, we get another useful limit. So the limit as x approaches a of x to the nth power is going to equal a to the nth power. Okay, I'm going to keep going. Similar limit holds true for roots. So we have the limit as x approaches a of x to the nth root is going to equal a to the nth root. In this one, you just want to make sure you note that n is still a positive integer. So second root, third root as examples. And finally, we have the 11th and last limit law, which is the root law. So this one we're looking at the limit as x approaches a of the square, the nth root of a function is equal to the nth root of the function at that value a. Keep in mind n is still a positive integer here. Okay, so that's our 11 limit laws. I know that's a lot, but we're going to be using these in class. And the important thing to remember is that these are going to make solving limits a lot easier, and you're going to understand the next thing we go over a lot better once you have these limit laws available to you. So bring this handout completed with you to class. We'll use it to go through our examples, and I will see everyone there.